Exercise 3. Let f be the function x, a radical 1 plus x. F of x equal radical 1 plus x. F of x is defined for 1 plus x greater or equal 0. So x greater or equal minus 1. Then the domain of definition of f is the interval minus 1 plus infinity. F is continuous and strictly increasing over the domain of definition. So f, it has an inverse function f minus 1. The table of variations of f of x varies from minus 1 to plus infinity, the domain of definition of f. For x equal minus 1, we have radical 0 equals 0. The graph of f start from the point minus 1, 0, this point. For x equals 0, we have f of x equal radical 1 equal 1, the point 0, 1. For x equal 1, f of x equal radical 2, or x equal 1, f of x equal radical 2. For x equal 3, 1 plus 3, 4, radical 4 equal 2, we have the point 3, 2. So we can draw the curve C of the function f. The graph of f in the interval minus 1 plus infinity. Now we must find f minus 1. We write y equal radical 1 plus x, and we calculate x in terms of y by squaring both sides. We have y squared equal 1 plus x. So x equal y2 minus 1 equal f minus 1 of y equal f of x equal f minus 1 of y. Therefore, f minus 1 of x is x squared minus 1. Domain of definition of f minus 1 is by the table is 0 plus infinity. 0 plus infinity. The image of the interval -1 plus infinity by f. The graph of f minus 1 is the symmetric of that of f with respect to y equal x. The two graphs intersect on y equal x. The symmetric of this point is the point on y prime y of ordinate -1. The symmetric of this point is the point 1, 0, 0, 1, 1, 0. So we can draw the graph of f minus 1. This part is the symmetric of this part with respect to y equal x. This part is the symmetric of this part with respect to y equal x. So the graph of f minus 1 is a part of a parabola in the domain 0 plus infinity. Y equal x square minus 1 is a quadratic function. The graph is a parabola. Thank you and see you later.